So, this idea of diffraction answers a question that you may have wondered, and that reminds me of one of my favorite radio ads of all time. And I got to go find this so I can play it for classes. I just haven't done it. There's a little 5-year-old or so girl, and she asks her dad, "Daddy, why is the sky blue?" And what does he say? He patronizes her, right? He says,
Is that the advertisement?
yes, this is, yeah.
No, I
mean, that's not all the advertising. I'm still in the middle of telling you.
No, I just wanted to make sure. I thought you just told me a story. I was like, what's the point?
All right. So he patronizes her. He says, "Well, to match your pretty little eyes," right? He's being kind of condescending, as if well, it's just the point is, in his mind, it's a girly answer, right? And what does the girl say? Well, actually, and she goes on to get the scientific explanation.
I wanted to see what the commercial was about.
It was something about bridging the gap of the gender differences in math and science, getting girls to study math and science.
That's what it was saying. Girl Scout. It was a long time ago. Yeah, I remember that commercial.
Okay. So anyway, she gives the actual explanation, which we're about to get to in a second. And then her dad goes, "Whoa, where did you learn that?" And what did she say? From mommy. So, anyway, I love that. From mommy.
Where did you learn that?
She learned that.
So anyway, so why is the sky blue? That's my question to you.
The sun is every single color, and blue is the most powerful color that gets through the Earth's atmosphere because the ocean is the only one we can see.
That's a good guess, but no.
Because the ocean.
I mean, you're close. Closer than you might even think. So here's me.
It comes into the tops of the ocean.
I'm standing on top of the world. And by the way, for one thing, figure not drawn to scale, obviously, and we're taking a palmate view, right? We're pre-Copernicus right now, just because it's easier to draw. So the sun is directly overhead. How does the sun get to me?
Very carefully.
Very carefully, yes. Through the atmosphere. Good. What's the atmosphere made of, mostly?
Water.
Nitrogen and oxygen. Oxygen and nitrogen are comprise like 65% maybe. I'm not sure on the number. It's a high percentage of the atmosphere, and then hydrogen is another big one. Right? Now, what are oxygen and nitrogen molecules, or all molecules for that matter, but especially small molecules, are mostly what? What? Okay, you got the protons and neutrons in a really tiny, compact nucleus. And then a fraction of electrons in clouds around them. What's between the electrons and the nucleus? Empty space. Atoms are mostly empty space. Right? There's a whole lot of empty space between those tiny nuclei and those electron clouds. So, it's like having a bunch of little holes for the light to pass through. Well, what do we just see that light or any wave will do when it passes through a hole? It bends. It diffracts. Now, the light you see, the light that comes from the sun is mostly whitish, which has all the colors mixed together, right? Let's talk about the colors for a second. What are the colors of the spectrum?
Red, orange,
Good.
red, green, blue, yellow, violet.
Good. Roy G. Bibb. Red, orange, yellow, green, blue, indigo, violet.
Cool, man. Talk about it. Cool, man.
What happens? Which one has a long wavelength?
Yellow. Red.
Red has a long wavelength.
Why does red have a long one?
It just,
God done that way.
well, I mean, it's red because it has a long wavelength. Yeah, I mean, it's not. It doesn't have a long wavelength because it's red. We call it red because it has a long wavelength. Now, the reason we call it red is it has a long wavelength. That's the property of the wave.
Don't worry, it'll come back.
I see a long wavelength as being red. That's what my eyes perceive it.
But how do I like it red?
We're getting to that. We're getting to the philosophical question. Yes. Believe me, that will be coming. Yes, it is what I call red because it's a long wavelength. All right, now, and so blue, indigo, violet have short wavelengths. Now, what's the relationship between wavelength and frequency? Inverse. So red has a low frequency, and violet has a high frequency. So as I go from from red to violet, the wavelength gets smaller, while the frequency gets higher.
So, G is like right in the middle?
Yes, sir. Now, I bring this up because with really tiny holes in the atmosphere, which are going to diffract, bend out first.
Blue. Obvious.
Blue. The short wavelengths will diffract first.
Is that why the sky's blue?
The way I kind of think of it is this. If I'm walking across something that's moving, which will bend more? If I take long steps or little tiny steps? Little tiny steps, right? Because each time I take a little tiny step, I get moved to the right. That's how I kind of think of it. It's just an analogy, not maybe a statement, but that's how I think. Now, so blue diffracts first. What else was there besides blue?
Indigo.
Well, yeah, indigo and violet kind of get mixed in, and our eyes aren't really sensitive to violet and indigo.
Green, which happens before tornadoes.
Right, but we got green, orange, yellow, and red, right?
I know that happens.
Which all of those, when mixed with blue, make white. So, if only the short wavelength spread out, then what two colors do we have?
Blue and white.
Blue and white, which makes
Light blue.
light blue.
Yeah, where's the light come from?
Okay, you got white light coming from the sun, right?
Oh, okay. Yeah.
If you spread out the blue, you can see this blue. And then who didn't spread out? The rest of the stuff that makes white. So we still have white plus blue equals light blue.
So why is the sun Why is the blue spread out?
Well, it's yellow because of its chemical composition. But the nuclear reaction it undergoes emits light of all different wavelengths.
Oh, okay.
Okay?
Wait, so how is white made?
Yeah.
White is all the colors mixed together.
But if the blue
So it's black.
spreads out, then how come you mix things together in this one? How come indigo doesn't spread out? Yeah, it's
Well, right. Well, but plus blue.
Yeah, so the blue is necessary for the white, so it's all the colors combined.
But you already have blue.
But if it's already spread out, then you can... Well, when the blue mixes with all the rest of the colors...
But it's also mixing out.
So if I get all these colors,
No.
when the blue mixes all the colors, it makes light blue. Yeah, dude.
Right.
Wait.
Because you still have blue separated.
They call everything a white, bro. It's just blue everywhere.
Okay.
Everywhere.
Makes good. Okay. Leslie.
No, she's like
She starts, yeah, she uses bigger words than I do. Yes, but
okay, so why doesn't the violet spread out?
it does. but your eyes aren't very sensitive to violet. Yes, Paul.
Okay, I still don't understand how the sun is yellow. I mean, if only blue and white get through the atmosphere, then how does yellow?
Well, no. The yellow's there. It's just mixed with the other colors in the form of white. Well, yeah, I mean, it's a yellow star, right, because of its chemical composition. Actually, what gases make up the star. But that gaseous, star is producing light in all the wavelengths, even though it itself is yellow in composition. It has to get larger.
What are the times they
the actual radius of the star.
There's one
It
I
could.
remember learning that in 8th grade.
Lots of things,
A
right?
long time before it explodes. Just saying.
Okay, hey, shut up. Please. Sorry, we just got too many conversations going on at once. What I just say? Okay, couple of things on that, right? One is, how do you interpret the passage that you're talking about? Does it literally mean that the sun that our Earth revolves around will literally turn red, or is it an image of something else that's going to happen? That's the first thing you have to decide. If it's really going to turn red, then you have to decide, okay, is it going to turn red supernaturally, like the Nile turning to blood, is supernatural, right? Or is it going to turn to red by natural means, which means it's going to become a red supergiant, which would mean that it would, its radius would greatly increase for its mass. So, I mean, there's a lot of different ways to look at that. All right, now, so let's continue this. Okay, real quick.
You start talking and ask the question.
Okay.
Why is the sky white, or why is the sky blue instead of white?
Because if the light don't come on,
Just why is it blue instead of white?
Because blue diffracts out and spreads out from the rest of the white.
doesn't the violet and indigo come with the red?
Yes, but our eyes aren't sensitive to violet and indigo. Now, when do you see the violet and the indigo? Like dusk, right before dawn, right before the sun rises. That's when you see the violet, because
Why do all the colors combine back together to make white if it's missing blue and indigo and violet?
But the blue, they all combine later.
But if they're all blue combined, why is it?
Okay, because what you're saying is that all the blue that was diffracted now is not diffracted, right? It's not separated from the rest of the white. We're saying that you got white. You're diffracting out a lot of the blue from the white.
All the colors diffract.
No, not at first. Not at first, right? And we're getting there, okay? So when the sun's above, here's the light. Here it comes. Ready? We'll do orange for this. Gets there, and as it travels through that atmosphere, only short wavelengths have the time, if you will, to diffract out.
Is that why, like, when you look out on the horizon, it's like really, really, really light, and then you look straight up and
Right now, look, it's white out there.
Actually,
does it have enough time
maybe. There's some other things going on there.
Poles, you see all the colors.
Because you're, now watch this. Again, Ptolemy, right? When the sun is here, light from the sun this time is going to be a green line. Just so it's different than the orange line.
So this is all metaphorical, right?
First of all, what happens to the light? It's not actually green. No. Now, first of all, what's going to happen to that green line when it hits the atmosphere? It's going to bend. Why? It's going to change the speed. It's going to speed up or slow down as it goes from space to the atmosphere.
Slow down.
Slow down. Is that going to go right or left?
Left.
Left, good. So it's going to bend this way. And hit me in the eye. Now, what color is the sun right now?
Green.
I'm sorry.
Yellow.
White. From my perspective. Yellow. Orange. Orange.
Green.
What color is the sky at sunset? Orange. Orange and red.
Oh, because it's bending to the...
Why?
Because it's
What?
There's more time for the light to look around.
There's more time because it's traveling through more nope,
Atmosphere.
of the atmosphere. See how this green line inside the atmosphere is longer than the orange line? So at sunset, which is depicted by the green line here, don't confuse that with the line and the color of the sunlight. But when it travels through more of the atmosphere, now what colors are going to diffract? The longer wavelengths. First yellow, then orange, then ultimately red.
That's why it was kind of like later.
That's why as the sun goes down, it goes through that yellow orange. Usually it gets just about a cloud. Usually a cloud.
Okay, so how is it different if it's coming from the side than from the top?
Okay? Yes, so what's different about the orange path and the green path?
Color, more
How much atmosphere it travels. Now, listen, because a lot of you are going to make this mistake, I promise. I'm going to try and stop you right now. Most common wrong answer on this question on the exam is the light has to travel farther at sunset. No. It's traveling farther, but by so little amount that you couldn't measure it compared to how far away the sun is. What matters is not that it travels farther, matters that it travels through more of the atmosphere. Which means it hits more oxygen and nitrogen molecules, which means the longer wavelengths diffract.
So the sun at sunrise or sunset travels through more of the atmosphere, and that's why it's a different color than like the rest of the sky.
But
The sun at normal blue diffracts more, it should diffract faster because it's like
well, it diffracts more easily, which means with fewer barriers, basically. Okay? Questions about why the sky is blue or the sunset's orange? Yes, Christian?
Why is the sky green before a tornado?
Anytime you have any kind of particulate matter, like dust being kicked up by high winds or pollutants or other things, those of course can affect the diffraction and change the color of the sky as well.
So would it be like any color other than green? Ever?
Tornado. I don't know. It's a good question.
Because like, we
That's
used
a-
to have like, up in Illinois, we have like white sky, but like it would come down, like a tornado would come down, like a white tornado.
Huh. That's interesting. So I guess it would depend on the nature of the wall cloud. Yes.
I got a say a couple years ago where the sky was like reddish, and it was like during the day, and it wasn't that like the sun, like the sunrise and the sky was like the entire sky was red.
Yeah.
And it was super windy.
Yeah. Yeah. Good question and good point. A lot of times, if you have a real bad dust storm or something, again, kick up enough dust up into the air, or sometimes the smoke. When we have those wildfires that we get the smoke blowing in from, those kinds of things in the atmosphere can change color as well. All right. Now, yes.
So like the northern lights and stuff, like when you see that has nothing to do with the atmosphere, it's just because of the electromagnetic pole, right? about, like, isn't the atmosphere, like, smaller at the poles? So wouldn't that explain, like, why you see more colors? Because it doesn't have to travel through as much atmosphere?
I mean, I would expect to see fewer colors with less atmosphere. If it were just that. If it were just the diffraction. Now, well, never mind, I won't go there. All right, now, I want you to notice one other thing. I want you to notice one other thing. We already mentioned it about the green line. Where does the sun appear to be right now?
Straight ahead.
Right there. But it's not. It's actually dipped below. When you see the sun setting, it actually has already set. No. It just looks like it's just now setting because the light refracts. And so you actually end up gaining a couple minutes of sunlight. Now once the sun actually goes down, then we have refraction, but then we also have some of the light reflecting off the atmosphere and refracting and diffracting from there. So that's why. You know, dusk and dawn before the actual sun comes up, there's still light. Okay? But I'm talking about the actual image of the sun is actually up before the sun's up. And yes, as Thomas just pointed out, because of the distance the sun is from the earth, the light you're seeing from the sun is actually only is 8 minutes old.
Yeah.
It left the sun 8 minutes ago. So yeah, if somebody turned off the sun, we wouldn't know for 8 minutes. And the closest star to us is like 1.4 light years away, and so when you look up at the star, isn't that Orion's shoulder? Good question. I should know that. And so that light is, left that star 1.4 years ago, and there's multiple stars in our galaxy that we can see that are hundreds of millions of light years away. And so the light that left them 100 million years ago, they probably, a lot of them don't even exist anymore. We're just seeing the light that left them.
So light at the top, is it in the same spot? Like, do you think it's in the same spot? You know what I mean?
Right. If it comes straight in, then it won't come back. Right. Just like the car going straight from Tower Top, it won't.
So does that mean that eventually, like, the Big Dipper's not going to be there anymore? Because, we're not going to be able to see the Big Dipper, one day we could look up, Big Dipper's not there.
Right. One at a time, probably, yeah.
Would it be dramatic, would we say like an explosion?
It depends on how it dies, right? If it has the critical mass that's large enough, then it will explode in what's called a supernova. And then if it has the critical mass from there, it can collapse into a black hole. If it doesn't have enough mass, then it just fizzles out.
Right.
Is the sun the closest star? What? Is the sun the closest star?
Wait, why wouldn't a black hole, heat up the whole
You didn't know that?
How come, if it's a black hole, why would it,
Beyond you, okay, it's finished.
If the North Star is disappears, sailors and stuff, they would have the star just disappear.
Absolutely. It's giving that GPS now, right? Yeah. Again, I've forgotten too much astronomy. I should know that, but I don't.
Come on, that's physics.
It is. It's a specialized branch of physics. That's it. Okay, now. Oh, by the way, I've got to give the little, maybe short version of this real quickly. Because it came up last period, and it bothers some people that I just said that we're seeing light that left another star hundreds of millions of years ago.
Earth's not that old.
the traditional Baptist, if nothing else, doctrine and the official stance of Prestonwood Baptist Church is that the earth is only tens of thousands of years old. Now, what I want to say first is, let's be careful. Don't confuse two similar but very, very different arguments. Right? For one thing, the important argument is naturalism versus theism. Right? A secondary argument that some people think is almost as important, if not as important, is the age of the earth. I feel like it's not nearly as important. If you are so inclined to think that way, though, there are a few explanations. Right? One theory says that God made the earth to look old, even though it's new. He created it like he created Adam as a full-grown human. He created the earth looking mature. In which case, they would say, in this case, he created not only the stars, but also the light en route. Right? So if he created a star that was 100 million light years away, then he created the star, and then photons of light traveling from the star to only a light year away from us or so that after creation, boom, the light would hit us and we would start seeing it immediately. That's possible. I'm not a big fan of that. Even if I were a younger person, I wouldn't be a big fan of that theory. Because it has at least a touch or tone of deception, if you will, or making things appear that they aren't. Especially when you start talking about things like supernova that occurred millions of years ago. Then God would basically put the light of the supernova in transit, even though the star that the supernova looks like it came from never existed. So now, again, I'm okay with that. Because you could say, well, it's like God's artistic license. He created the light of the supernova as something to awe us and inspire us, even if it wasn't a star that was beginning there. But it's not my favorite explanation. The most convincing argument I've ever heard for somebody who is a younger creationist dealing with this matter of the stars was a man by the name of Russell Humphreys, who's written a book. And we're going to touch on this lightly at the end of the year when we talk about relativity. But basically, gravitation slows down time. And so Humphrey says, well, if the Earth is near the center of the universe, when everything was created, the center of the universe would be very, 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 very dense, right? And therefore a very, very, very strong gravitational field. There could be stars on the outskirts of the universe right after creation that would experience less gravitation, right? So time would travel faster for those stars than it would for Earth.
But is it a fact that time travels faster?
Absolutely.
Oh.
Yeah.
How much?
It depends on the strength of the gravitational field. I mean, significantly. And so, you're saying that thousands of years on Earth then could be millions of years for one of those distant stars. That, to me, is a lot more tenable, and it makes a lot more sense. Although I don't have to have that. I'm okay with an old Earth and an old universe, personally. But I didn't say that on recording. I just did. Okay?
Recording this whole thing?
Yes. Including all your outbursts, yes. Future ones. Okay. All right. Now, so we've dealt with why mirages form. We've dealt with why the sky is blue. We've dealt with why sunsets are orange. We've dealt with why objects appear shallower in water than they actually are. We've dealt with how we get a few extra minutes of sunlight each day, and which of the phenomena creates each of those scenarios, right? Either diffraction or reflection or refraction. Right.